Okay, pre-calc students, we're still working on the Unit 6 review, and we're now on page 2. In this section, we're talking about discontinuity. So in the first function, we're going to factor the numerator and denominator. The numerator has a common factor of x times x plus 4, and the denominator factors as x plus 4 times x minus 7. So the factor of x plus 4 cancels out, which tells us that there is a whole at x equals negative 4. The factor of x minus 7 does not cancel out in the denominator, so that tells us that there's a vertical asymptote, or that there is infinite discontinuity at x equals 7. The second function's a little bit more complicated. Again, we're going to factor the denominator. So the denominator is a big square root of x squared times x plus 1. The square root of x squared is just x, so this becomes x over x times the square root of x plus 1. The x and x cancel out, and we get 1 over the square root of x plus 1. So because we canceled out a factor of x, we know that there's a whole at x equals 0. Now normally, anything that would make your denominator 0 would be a vertical asymptote. Because this is a square root, though, the domain of this function actually begins at negative 1. So instead of being an asymptote, it's going to be a whole of a starting point. So this function is continuous over its whole domain of negative 1, not including negative 1 to infinity. So the only point of discontinuity within the domain is the whole at x equals 0. The next section, we're talking about domain and range and deciding whether or not the relation is a function. The domain is going to be from the beginning x value to the ending x value, so that will be negative 4 to 6, including the endpoints. The range is going to be from the bottom of the function, the smallest y value, to the largest y value, and so that one's going to be negative 3 to positive 2. The function does pass the vertical line test, and so we'll say yes, it's a function. In the second set of points, the domain is only the given x values, not the values between it, so you need to use the fancy brackets and just list the x values. I usually list them from smallest to largest, 2, 3, 4. If there's a repeat in the x values, don't write it. The range will be the y values. Again, I like to write them from smallest to largest. So the smallest would be negative 5, then negative 1, positive 1, and 10. To decide whether it's a function, you're looking to see if any x value repeats with different y values. Here I can see that an input of 2 gives you an output of 1, or it can give you an output of negative 1, and this is how I know that this one is not a function. And the third one, your domain is going to be from your smallest x value to your largest x value, and these are going forever. So my domain starts at negative 3, and I want to include that, and it keeps going until infinity. My range is from my smallest y value, and these arrows are going forever down, to my largest y value, and these are going forever up. So my range is negative infinity to infinity. However, we do not pass the vertical line test here, so this graph does not represent a function. Okay, deciding the domain of a square root function. Remember, you cannot take the square root of a negative number. So you need to say that whatever's underneath the square root has to be greater than or equal to 0, and that's how we know it's not negative. Then you solve that by subtracting the 3, and then dividing by negative 5. When you divide by a negative on both sides, you have to flip your inequality. So now I have x is less than or equal to 3/5. So I want to include the 3/5 with a square bracket, and I want to go less than that number all the way to negative infinity. In B, I have a denominator. Your denominator is not allowed to equal 0, so I'm going to write 5x minus 15 cannot equal 0. which means 5x cannot equal 15, and x cannot equal 3. So my domain is all real numbers except for 3, and in interval notation that would be negative infinity until 3, and 3 to infinity. In C, I have a square root and a denominator. Now I know because of the square root, 9 plus 6x has to be greater than or equal to 0. However, because it's a denominator, it also can't equal 0. So I'm going to take the or equal to off there. Now I have 6x is greater than negative 9, and when I divide by 6, I get x is greater than negative 9 over 6. That simplifies to x is greater than negative 3/2. And in interval notation, that would start right after negative 3/2 and go to infinity. In D, I have a quadratic under a square root, so this is when you have to test for key points. First, I start by factoring the quadratic, so I get x minus 11 times x plus 11. And these give me my key points of positive 11 and negative 11 on my number line. I need to test a point in each section, x and y. So I test something smaller than negative 11, I'm going to test negative 12. I test something between the 2 points, like 0, and something greater than 11, like 12. If I plug negative 12 into each factor, negative 12 minus 11 is a negative number. Negative 12 plus 11 is also a negative number, and negative times negative is positive. If I plug 0 into each factor, 0 minus 11 is a negative number, 0 plus 11 is a positive number, and negative times positive is negative. If I plug positive 12 into both factors, 12 minus 11 is positive, and 12 plus 11 is positive. Positive times positive is positive. So, the first set of products is positive, which means I can take their square root. The second set of products is negative. I cannot take the square root of that negative. And the third set of products is positive, so I can take their square root. So my domain is everything less than or equal to negative 11, and also everything greater than or equal to 11. In interval notation, I write negative infinity to negative 11, including it, and 11 to infinity. You want to do the same thing for E. When you factor your denominator, you're going to have x squared times x plus 4, and that gives me key points at x equals 0 and x equals negative 4. So I need to test a point in each section. Something smaller than negative 4 could be negative 5. Between the two, I can choose negative 1, and greater than 0, I choose 1. Whenever I plug any number into x squared, it's going to turn positive. So I know that these y's will all start with positive. When I plug negative 5 into x plus 4, I get a negative. When I plug negative 1 into x plus 4, I get a positive. And when I plug positive 1 into x plus 4, I get a positive. So this gives me a negative product, and a positive product, which means I cannot take the square root of these numbers, but I can take the square root of these numbers and these numbers. So starting at negative 4, my domain goes all the way to infinity. And the last set is a cube root. Remember that a cube root function is defined for all real numbers, so my domain is negative infinity to infinity, regardless of what's underneath it. Let's turn the page. Alright, on page 6, we are graphing transformations of our parent functions. You have to know your parent functions, so go back to your day 2 notes if you don't know your parent functions and practice those before you move on. Now we're going to be transforming them, so I know my shape of my cube root graph is something like this. This is what I'm transforming. I have to move left 3 and down 2. So moving left 3 and down 2, that's my new center point. Normally I would have a point over 1 and up 1, back 1 and down 1. If I'm going to make another point, it would go over 8 and it would go up 2. and then it would go back 8 and down 2, but that one's off the graph. For cube root, your domain's all real numbers, and your range is also all real numbers, and this cube root function is always increasing, and it's never decreasing. Let's look at the end behavior. As x goes to positive infinity, my y is going up. It's going to positive infinity. As x goes to negative infinity, the y is going down, so it's going to negative infinity. The next one's absolute value, so your parent function is the v shape. I have a vertical stretch of 2. I have a vertical flip because of the negative, and my vertex moves up 3. So my vertex goes from 0, 0, up 3. Instead of going over 1, up 1, I go over 1, down 2. That is both my stretch and my flip. And I continue doing that on both sides, only for the absolute value function. So my domain is all real numbers. My range starts down here at negative infinity and goes all the way up to my maximum value of 3. And I want to include 3. It's increasing on the left half, so it's increasing from negative infinity to 0, and it's decreasing from 0 to infinity. For increasing and decreasing, always use parentheses. You never use a square bracket on increasing and decreasing. As x goes to positive infinity on the right side, the y values are going down. They're going to negative infinity. As x goes to negative infinity on the left side, the y values are also going down. They're going to negative infinity. C is a rational function. The parent function of the rational has asymptotes on both axes, and it has branches in the first and third quadrants. My rational function is going to move left 3 because x plus 3 is inside the function. So I'm going to move my vertical asymptote over 1, 2 to x equals negative 3. My horizontal asymptote stays at y equals 0. And there's no stretch, which means my points are going to be over 1 and up 1, and back 1 and down 1. If you remember from your parent function, you also had a point that was over a half and up 2, and over 2 and up a half. And then do your best to draw those branches in so that they're hugging those asymptotes. Okay, your domain is everything except for your vertical asymptote. You have to leave out negative 3. In interval notation, that's negative infinity to negative 3, and negative 3 to infinity. Your range is everything except for your horizontal asymptote, so you have to leave out y equals 0. Negative infinity to 0, and 0 to infinity. This function is decreasing in this piece, and is also decreasing in this piece, so it's never increasing. It decreases from negative infinity to 0, and then from 0 to infinity. Your end behavior is different for a rational function. As x goes to positive infinity, your y value is getting closer and closer to your horizontal asymptote, so it's actually approaching the number 0. And as x goes to negative infinity, again, your y value is getting closer and closer to your horizontal asymptote, so the y value is approaching 0. In D, we're doing a cube function. A cube function is this shape. The middle of my function is shifting right 1 and down 3. So here's the center. I'm going to go over 1 and up 1 on both sides. And if you have room for another point, that point would be over 2 and up 8. And on this side, I think we're out of space. So your domain and range is all real numbers for each of these, and it's increasing from negative infinity to infinity, so it's never decreasing. The end behavior, as x goes to positive infinity, y is going to positive infinity, and as x goes to negative infinity, the y is also going to negative infinity. Here's a square root function. Normally, the parent function is like a rainbow. This is going to have a vertical flip because the negative's outside the function. It's also going to shift left 1 and up 3. So I'm going to start by moving my point from 0, 0, left 1 and up 3. And normally I would go over 1 and up 1, but because it's flipped, I'm going to go over 1 and down 1. Normally I would go over 4 and up 2, but because of the flip, I'm going over 4 and down 2. Your domain starts at this start point, so I start at -1 and go all the way to infinity. Your range starts at the bottom at -infinity and goes up to a maximum value of 3. This function is never increasing, it's only decreasing. It's decreasing over its domain. Oops, this one is none. So it's decreasing from -1 to infinity. As x goes to positive infinity, your y is going to negative infinity, and x doesn't go to negative infinity, so this one is not applicable. Lastly, we have a quadratic function, which would be your parabola. Normally the vertex is at 0, 0, but because of x minus 2, it shifts right 2. And then because of the negative in front, we're going to have a vertical reflection, so instead of going over 1, up 1, we go over 1, down 1, over 1, down 1. Instead of going over 2, up 4, we go over 2 and down 4. From the vertex, over 2, down 4. So the domain is all real numbers. This is going to negative infinity, this is going to positive infinity. The range starts at negative infinity and goes to a maximum value of 0. It's increasing on the left half, so it's increasing from negative infinity until 2. And then it's decreasing from 2 to infinity. The end behavior is down on both sides, so as x goes to positive infinity, the y is going to negative infinity. And as x goes to negative infinity, the y is going to negative infinity as well. Okay, this is the end of page 3, and we will continue on a new video.